when you're wanting to go from atoms to grams or grams to atoms, you have to use dimensional analysis. Remember, the idea behind dimensional analysis is you're not changing the amounts, you're changing the units. So, for example, if you're wanting to know how many atoms there are in a certain number of grams, you set it up to where question mark atoms, and when you're talking about a single element, that's when it's atoms. When it's more than one element, then you're talking about molecules. But you do it exactly the same way for both of them. So you've got how many atoms you're looking for. Grams is what you're given. You set it up to where your grams are going to cancel, and you know how many grams there are in a mole because that's given to you on your periodic table. So your grams in the mole, and then in a mole you know that there's 6.022 times 10 to the 23rd atoms. So then your grams are going to cancel out, your moles are going to cancel out, and leaves you with atoms, which is what you're looking for. When you're going back the other way, how many grams are in a certain number of atoms? You know there's 6.022 times 10 to the 23rd atoms in 1 mole. And then you know in 1 mole how many grams you've got. So the atoms will cancel, the moles will cancel, leaves you grams, which is what you're looking for. So let's do a problem. Say you're given the problem how many grams are there in 6.33 times 10 to the 24th atoms? So you set it up. How many grams is equal to 6.33 times 10 to the 24th atoms? And you're doing this with calcium. Okay? Well, you know that you have 6.022 times 10 to the 23rd atoms in 1 mole of calcium. And then you look up on your periodic table and you see that in 1 mole of calcium you've got 40.075 grams. Now, when you're multiplying this out, you remember you multiply across the top, then you multiply across the bottom, then you divide the bottom into the top. So you're going to get 6.33 times 10 to the 24th times 1, which we're just going to ignore that, times 40.075. Then you're going to divide that by 6.022 times 10 to the 23rd times 1. Okay? Now, when you're setting this up in your calculator, the way that I do it is I do 6.33 times 10 to the 24th times 40.075 equals divided by, and here's the trick, you've always got to put this in parentheses, 6.022 times 10 to the 23rd, parentheses equals. If you don't put it in parentheses, what happens is your calculator looks at it, it takes this number, divides it by 6.022, and then it multiplies everything by 10 to the 23rd. And when you do that, you get some screwy numbers like 10 to the 48th or something like that. So make sure you do it that way. And when you run the numbers on it, you get 9.24 times 10 to the 23rd atoms of calcium. Okay? Now, the only other difference is when you're running a question that instead of having atoms, you've got something like K3N. So the first thing you have to do before you can do this problem is you have to figure out how many grams there are in 1 mole of K3N. And the way that you do that is you figure up on the side here, you've got potassium and you've got nitrogen. You've got 3 of these, you've got 1 nitrogen. Now you look on your periodic table, you see that potassium is 39.098. And you see nitrogen is 14.007. Multiply that out. Add them together. And that's how many grams there are in 1 mole of K3N. Okay, so potassium nitride has 131.301 grams. In 1 mole. Okay, so you get, now that you have that, now you do the problem just like we did before. If you say how many grams are there of K3N, let's do molecules this time. How many molecules and when you're doing your abbreviation, make sure that you abbreviate MOLEC or something like that. Because if you abbreviate it MOL or MOLE, you're going to be confusing it for moles later on. Okay, so how many molecules are there in 300.04 grams of K3N? Okay, well you know you've got 100, if you've got grams here, you got to have grams down here so they'll cancel. So you get 131.301 grams of K3N in 1 mole. And then you know in 1 mole, 6.022 times 10 to the 23rd molecules. Run the numbers on that, and you get 1.38 times 10 to the 24th molecules of K3N. That's it.